Very good morning, friends. Today we'll continue lecture number 6 on permutation and combination. Basically, in this lecture we'll be doing some more problems on permutation. So let us begin lecture number 6 on permutation and combination. Problems on this. In a group photograph, 6 teachers are in the first row, 18 students are in the second row. There are 12 boys and 6 girls among the students. If the middle portion is reserved for principal and if no two girls are together, find the number of arrangements. This is first row and this middle seat is what for principal. So we will first arrange first row and then we'll go for second row. Arrangement in first row. Principal in center of first row. Can be arranged in one way. The 6 teachers at 6 different places in first row can be arranged in six factorial ways. Therefore, number of arrangements in first row one into 6 factorial. 1 is for principal and 6 factorial for teachers. Now we'll go to our second row. Arrangement in second row. Now here 12 boys and 6 girls. Girls are not sitting side by side. तो नखरे किसके हैं? गर्ल्स के. तो फर्स्ट विल अरेंज बॉयज. 12 boys at 12 different places In second row, can be arranged in 12p12, 12 factorial ways. For 6 girls, there will be 13 possible places in second row where no two girls are sitting side by side. Therefore, 6 girls at 13 different places. In second row, can be arranged in 13p6, 13 factor upon 13 minus 6 factorial. Therefore, number of arrangements in second row will be 12 factor for boys and 13 factor upon 6 factor for girls. This is arrangement in second row. For photograph, total number of arrangements in first row and second row is equal to 6 factorial for first row into 13 factorial, 12 factorial upon 7 factorial, sorry. 6 factorial into 12 factorial into 13 factor upon 7 into 6 factorial. 6 factorial will get cancelled. So many photographs we can click. Next problem is what? Find the number of ways so that the letters of word history can be arranged as number 1, Y and T are together. Y and T are together. In this case, we will take Y and T in one group. So history contains 7 letters, Y and T together, therefore one group of Y and T plus say 5 other letters, 1, 2, 3, 4, 5, 6, 7. Is equal to 6 at 6 different places in a row can be arranged in six p6, 6 factorial, 720 ways. Now Y and T, which are in group, among themselves can be arranged in two p2, 2 factorial is equal to 2 ways. Therefore, total number of arrangements (720 into 2) 1440 ways. One 1440 arrangements are there. B part is what? Y is next to T. Y is next to T. Since Y is next to T, therefore we will take Ty as 1 unit. Therefore, 1 unit plus 5 other letters is equal to 6 at 6 different places in a row can be arranged in 6p6, 6 factorial, 720 ways. In this case, we will not arrange Ty, because when we will arrange Ty, then instead of Ty it is what Yt it will become. So just we need Ty only. The total arrangement will be 720. Next one is third one. There is no restriction. There is no restriction. Seven letters in the word history among themselves can be arranged in 7p7, 7 factorial is equal to 5040 ways. So whenever there is no restriction, it will go anyway. That is 5040 words we can prepare. Next one is begin and end with vowel. Begin and end with vowel. The word history contains two vowels. I and O. Contains two vowels. That is I and O. To begin with vowel, we can arrange in One way. To end with vowel, to begin with vowel, we can arrange in two ways, sorry. To end with vowel, we can arrange one way. The remaining five letters between them between them can be arranging five p 5 factorial 120 ways. Therefore, total number of arrangements will be 2 for beginning, 120 between, and 1 for ending. 240 ways. E part is what? End in ST. End in, that means word end with what? ST. To end in ST, we can arrange in one way. Now remaining five letters in beginning can be arranged in five p 5 factors equal 120 ways. Therefore, total number of arrangements is equal to 120 into 1 of ST is equal to 120 ways. One more part is there. Begin with S and end with T. Begin with S and end with T. To begin with S, we can arrange in one way. To end with T, we can arrange in one way. The remaining five letters between them can be arranged in 5p5, 5 factorial is equal to 120 ways. Therefore, total number of arrangements is equal to 1 for beginning, 120 between, and 1 at the end. One 20 ways. Find the number of arrangements of letters in the word Solapur so that consonants and vowels are placed alternately. The word Solapur contains OAU, three vowels, SLPR, four consonants. The word Solapur contains four consonants and three vowels. Four consonants at four alternate places can be arranged in 4p4, 4 factorial ways. Three vowels at three alternate places can be arranged in three factorial ways. Therefore, total number of ways in which consonants and vowels are alternate is equal to 4 factorial into 3 factorial 24 into 6 144 ways. See the working. Since consonants are 4 but vowels are 3, so there is only one possibility: CV, 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 C. It will not give you what VC, VC. Otherwise, at the end, two consonants will be together. First consonants can be arranged in 4 ways. First vowel 3, second consonant 3, then second vowel 2, third consonant 2, third vowel 1, fourth consonant 1, which is what 4 into 3 into 2 into 1 will give you what 4 factorial. Then remaining 3 into 2 into 1 will give you what 3 factorial. If consonants and vowels will be equal in number, then there will be two possibilities: VC, 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 or CV, CV, CV. If suppose vowels and consonants are equal in number, then it will be, for example, 3 vowels, 3 consonants. Then the element will be CV, CV, or VC, VC, VC. So here it is what 3 factorial into 3 factorial, or means add again 3 factorial into 3 factorial, which will give it 2 times. This will happen when vowels and consonants alternately, but they are equal in number. Then it will be 2 times. And if vowel is more than consonants or consonant is more than vowel, then it is only one arrangement. So this is what we have to remember. So in this case, 144 will be the answer. Find the number of 4 digits, numbers that can be formed using digits 1, 2, 4, 5, 6, 8, if digits can be repeated. Case 1, when digit can be repeated. Total 6 digits are there. We are forming four-digit numbers. which can be formed in 6p1 into 6p1 into 6 into 6 into 6 raised to 4, 1296 numbers. Second case is what? A repetition of digit is not allowed. In this case, 4-digit numbers can be formed in 6p4, which is 6 factor upon 6 minus 4 is what? 2 factorial. 6 factor is what? 720 upon 2, 360 numbers. How many numbers can be formed using digits 0, 1, 2, 3, 4, 5 without repetition, so that resulting numbers lie between 100 and 1000? Numbers lying between 100 and 1000 means 3-digit numbers. Since or at hundreds place, we can arrange any one of the 5 non-zero digit. At hundreds place, we can arrange any one of the 5 non-zero digit in 5 ways. Since repetition of digit is not allowed, but now we can include 0. Therefore, again there will be 5 digits which can be arranged at remaining two places. That is tens and units. Yes sir, आइए प्लीज, आइए आइए, नॉट एट ऑल, बस ठीक है. So once again let me explain. Number of numbers lying between 100 and 1000 means 3-digit numbers. At hundreds place we can arrange any one of the 5 non-zero digit in 5 ways. Repetition of digit is not allowed, but now we can include 0. Again there will be 5 digits which can be arranged at remaining two places, that is tens and units place in 5p2 is equal to 5 minus 2 is what, 3 factorial, which is equal to 5 into 20 ways. Therefore we can form 5 ways hundreds place and 20 remaining 2. 100 numbers. Find the number of 6-digit numbers using digits 3, 4, 5, 6, 7, 8 without repetition. How many of these numbers are 6 digits are given and we are forming 6 different digited number. We can form in 6p6, 6 factorial, 720 ways. Now in the first part we want divisible by 5, A part. To get number divisible by 5, at units place 5 can be arranged in one way. Remaining 5 digits at remaining 5 places can be arranged in 5 p 5, 5 factor is equal to 120 ways. Therefore, we can form 120 into 1. This is 125 places and 1 way unit place. 120 into 1 is equal to 120 numbers which are divisible by 5. B part is what? We want not divisible by 5. Out of 720 numbers, 120 numbers are divisible by 5. Therefore, 720 minus 120 is equal to 600 numbers are not divisible by 5. A code word is formed by two different English letters followed by two non-zero digits, distinct digits. Find the number of such codes. Also find the number of such codes words that end with an even digit. Selection of two distinct letters. Out of 26 letters, two distinct letters arrangement of two distinct letters. Out of 26 letters, two distinct letters can be arranged in 26p2, 26 factor upon 24 factorial, 26 into 25 into 24 factor upon 650 ways. Now, there are two cases for arrangement. Case 1. Two non-zero digit string digits can be arranged in 9p2 9 factor upon 7 factorial 9 into 8 into 72 ways. Therefore, total number of codes that can be formed in 650 into 72 46,800 ways. Now, also find number of such code words that end with an even digit. To end with even digit, we can arrange in 2468. That is 4 ways, and other digit can be arranged in out of remaining 8 digits. 8 non-zero digit in 8 ways. Therefore, 2 digits can be arranged in 8 into 4, 32 ways. Therefore, number of codes that can be formed in 650 into 32. 650 ways, the 2 letters, and 32 the digits. $20,800 ways. So many codes we can form. Find the number of ways in which 5 letters can be posted in 3 post boxes. If any number of letters can be posted in a post box. The first letter can be posted Three post boxes in 3 ways. Since any number of letters can be posted in any one of the three post boxes. Therefore, second letter can be posted in three post boxes in 3 ways. Third letter can be posted in three post boxes in 3 ways. Fourth letter can be posted in three post boxes in 3 ways. Fifth letter can be posted in three post boxes in 3 ways. Therefore, total number of ways in which 5 letters can be posted in three post boxes in 3 into 3 into is equal to 3 raised to 5, 243 ways. अब अभी याद से वो गिलास का और इसका पैसा ले लेना, मुझे दिमाग से निकल जाएगा. Find the number of arranging 11 distinct objects taken 4 at a time so that a specified object always occur, never occur. So this total 11 objects are there. Out of which we are arranging 4 objects. First, a specified object. always occur. Specified object never occurs. First, when we are selecting, now first we need to select. First we need to select, and after selecting, then we will be arranging them. So when we are selecting one specified object, that means we have to take from backdoor entry. We will not go according to combination way. एक ऑब्जेक्ट को पहले ले लो, then out of remaining 10 objects, 3 more objects can be selected in 10C3 ways. ऐसे करेंगे. When we are selecting one specified object, then out of remaining 10 objects, three more objects can be selected in 10C3, 10 into 9 into 8 upon 1 into 2 into 3, 120 ways. One object already we have taken, now we have taken 3 more objects. The 3 objects can be taken in 120 ways. Now in the selection we got one, that particular object, then remaining 3, 4. Like this. हाँ लेक्चर में हूँ इधर पार्ला. ओके ओके. Selected in 10C3, 120 ways. Therefore now selected 4 objects can be arranged in 4P4 4 factorial 24 ways. एक सिलेक्शन का 24 अरेंजमेंट हो गया. And like this there are 120 ways of selecting 4 objects. Therefore total number of objects, number of arrangements is equal to 120 into 24 2880 ways. And second part is what? A specified object never occurs. When a specified object never occurs. Out of that means we are out of 11 object, we are removing one object. We don't want that. Out of remaining 10 objects, 4 objects can be selected in. Out of remaining 10 objects, 4 objects can be selected in ten C4 2 4 ja 3 3 ja or 4 to ja it cancel 3 3 ja 3 7 ja 21 210 ways. Now selected 4 objects can be arranged in 4P4 4 factorial 24 ways. Therefore, एक सिलेक्शन का 24 अरेंजमेंट लाइक दिस 210 सिलेक्शंस आर देयर. Therefore, total number of arrangements will be 210 into 24 is equal to 5040 ways. In how many ways can 5 different books be arranged on shelf if there are no restrictions? 2 books are always together, 2 books are never together. 5 books, no restriction. 5 books at 5 different places. On shelf. Can be arranged in 5P5, 5 factorial is equal to 120 ways. Now second, 2 books are always together. Two books we will take one unit. Therefore, 1 unit plus 3 other books is equal to 4 at 4 different places. Can be arranged in 4p4 4 factorial 24 ways. Now, the two books which are taken as 1 minute among themselves can be arranged in two p2 is equal to 2 factorial 2 ways. Therefore, total number of arrangements is equal to 24 into 2, 48 ways. Third part is what? Two books are never together. Never together. Out of 120 arrangements, out of total 120 arrangements, 48 arrangements in 48 arrangements, two books are together. Therefore, 120 minus 48 is equal to 72 arrangements has two books never together. Three boys and three girls are to sit in a row. How many ways can this be done if there are no restrictions? Total number of students 3 plus 3 6. There is no restriction. Six students at six different places in a row can be arranged in six p6 6 factors equal to 720 ways. Second is what? There is girl at each end. One girl at first end can be arranged in three P1, sorry, three girls are there. Is equal to three ways. One girl at other end can be arranged in two P1 is equal to two ways. Remaining four students three boys and one girl is left. So four students. Between them can be arranged in 4P4, 4 factorial, 24 ways. Therefore, total number of arrangements will be 3 into 24 into 2, 144 ways. Third case is what? Boys and girls are alternate. Alternate. Boys and girls are alternate, can be arranged in BG, BG, BG or GB, GB, GB. This can be done in three factorial into three factorial plus 3 factorial into 3 factorial is equal to 2 times 3 factorial into 3 factorial. 72 ways. Fourth is what? All boys sit together. In this case, all boys we will take in one group. Therefore, one group plus 3 girls is equal to 4 at 4 different places in a row can be arranged in 4p4 4 factorial 24 ways. The 3 boys who are in group among themselves can be arranged in 3p3 3 factorial is equal to 6 ways. Therefore, total number of arrangements will be 24 into 6 is equal to 144 ways. Thank you so much. Today's quote is, सपनों को सच करने से पहले सपनों को ध्यान से देखना होता है. Before making the dream success, you have to carefully see the dream. Thank you very much.